So what I'd like to do next is just to answer a couple of questions on the tutorial so you can see what I'm looking for in terms of the answers. Right, so let's log in again. There we go. I'm going to be Harry for now, just to make things easy for me. So I'm going to do sketching graphs and find the equation of the lines that pass through these points. Right, before I do this, let me just review how this works. So -4, -5, and then 4 and 11. Okay, so these are 2 points. Let's just see what they look like. So that's -4 on the x and -5 on the y, so that's down there. 4 on the x and 11 on the y, so that's up there. So I've got a line that's doing something like that. So looking at that, you can see that it's a positive gradient, so m is greater than 0, and we've got an intercept. Remember, this was -5, that's +11, so that's going to be, I don't know, about 5-ish, something like that, I would guess. So just looking at those 2 points, I'm just making a guess of what the curve is likely to be. Now remember, y is equal to mx plus c. Okay, so m, the gradient, is equal to the change in y, which is called dy, divided by the change in x, which is obviously dx. So that is equal to, let's do the change in y, so it's going to be 11 minus -5, so that's going to equal 11 minus -5, and that's going to be divided by 4 minus -4. Okay, so 11 minus -5 is going to be 16, 4 minus -4 is going to be 8, so the gradient is going to equal 2. So we've now got the gradient, but we now need to find the y-intercept. So let's just remind ourselves, y is equal to mx plus c. So that means that c is equal to y minus mx. Okay, I've moved the c, I've just swapped it round, so I've moved the mx onto the same side as the y, and then I've put the c like that. So that means that c is equal to y. Now let's take this first point here. So y is 11 there, so that's 11 minus m we've calculated to be 2, so that's 2 times the x value here is 4. 2 times 4 is 8, 11 minus 8 is equal to 3. Okay, and then for sanity, let's do the other equation. So this time c is equal to, I did the 11, so -5, and then it's going to be sorry, that's not a very good 5, let me do another 5 that looks a bit more like a 5, and then it's going to be -2 times, and then the x value is -4, so it's -4. I need a bracket there. Okay, -2 times -4 is +8. +8 minus 5 is equal to 3. So we have 1 there and 1 there, and they're both the same, so my sanity check says that we're okay. So I'm just going to slide that off the screen, but it's still visible to me because I'm going to put this into here. So this is what I would expect out of baseline. So what I'm going to say is find the line through brackets -4 comma -5 and brackets 4 comma 11. Right, have I done that right? -4 -5, and then when I press enter, watch the top of the screen, it says, right, my answers have been saved. So that's the first answer that I've saved. So now what I want to do is I want to say that m is equal to dy by dx. Okay, and so that is equal to dy, which is going to be, I'll need a bracket, so I'm going to say 11 minus brackets -5, so that's dy, close that bracket, divided by 4 minus brackets -4. Okay, close bracket, and remember with your brackets, count 1 for the opening brackets and -1 for the closing bracket, so I get 1 2 1 0 1 2 1 0. So that's great, my brackets work out. And here I've started the line with an equal sign because I haven't changed the m, so that this line means I'm still looking for m, and I'm still looking for m, and that's going to equal 11 minus minus 5, so that's 16, divided by 4 minus minus 4, so that's 8, okay, and that is equal to 2. So that's my gradient. Then what I'm going to say is when y, so before I do that, so what I'm going to say is that c is equal to y minus mx. So when y equals 11, y equals 11, x equals 4. Maybe you don't need that line, but it won't hurt. So now what we're going to say is that c is equal to, what have we got, 11 minus 2, and remember times is a star, you've got to use a star, don't use an x, because it'll assume that that's the variable x, not a times, and it's 4, so that's 4, so therefore that c is equal to 3. Okay, so at this point you can just go straight for the answer if you want. You can do a sanity check if you want. At the moment I'm not insisting on a sanity check, but so you know, that will be on your exam paper. So now I would say answer colon y is equal to, the gradient was 2 if you remember, so it's 2x, and then we've got 3 there plus 3. Okay, and when I press enter for the last time, my answer has been updated, so that is how you'd put the answer in. So let me just make that a bit bigger, because you can stretch these things. So I've started by stating what the question is, find the line that goes through those things. I've then said this is how you find the gradient. I've then found the gradient, okay, then I've said this is how you find the y-intercept. I've then found the y-intercept, and then I've stated my answer. Okay, so that is a full answer to the question. It's given you all of the bits that you need to answer that question fully. And just so we're clear, if you just gave me the answer, I would give you the mark, but if you just gave me the answer on an exam paper, I wouldn't. You need to show the working on an exam paper, which is why we're doing this with baseline. Is that all right? So that's question 1A, 1B, 1C. They're all much of a muchness. Right, question 2 is similar, okay, except we're talking quadratics here instead of straight lines. Let me just see what the other questions are like. The Wayne Tumbler. All right. What's the Wayne Tumbler, I hear you ask? Have we got a couple of minutes? What do you think, Sarah's? Shall I show the Wayne Tumbler?
Yeah, go for it. I think so.
Okay. Just got to remind myself where it is. The Wayne Tumbler. So this is from Batman Begins, if anybody's interested.
What's that? Well, the tumbler? Oh, you wouldn't be interested in that.
She was built as a bridging vehicle. During combat, 2 of these would jump over a river towing cables. And over here on the throttle, flip that open and throttle up. This will boost you into a rampless jump.
Disengaged.
We never could get the damn bridge to work, but this baby works just fine. So what do you think?
Does it come in black?
So, have we got any questions? Ashley. Okay, so the Wayne Tumbler jumps, okay? It jumps across, and you can see in the question in baseline, it jumps from this place to this place. The tumbler is measured at the following points. Okay, so we've got 3 coordinates. So I'm looking for you to calculate an equation out of that. So that's the Wayne Tumbler. So now you know it's a jumping machine. It's a car that can jump. Maximum height. Okay. Golf balls. Right. obviously we know where we're going with golf balls. So first of all, you've got a circle, and I want to put a circle in a hexagon, so you need to work out the size of the hexagon. So let me just show you with that. So what I'm talking about here is I want a circle inside a hexagon. Okay, so you've got a circle with a given radius, and you need to fit it into a hexagon such that this are all tangents. Okay, so that's what that is looking for. And obviously what I'm then going to go on to is sticking golf balls in a box. Clearly I'm thinking of atoms in a lattice here, you understand, but I also did work for Dunlop and I did have to put golf balls in a box. So what I'm interested in is the volume of this box with only one layer and the volume of this box with one layer. So is this a higher volume than this or a lower volume? That's really what that's for. So that's question 4. Question 5. Yeah, okay. Frankly, you're mad if you don't use Excel for this. So what would I expect you to do from here? I'd say putting the data into Excel, E-X-E-E-L. Okay, so that's that. You'd put the data in, you'd get the gradient. So we'll estimate the gradient of the line of best fit. So then you'd say gradient equals, I don't know, 5.2 or whatever it happens to be. That is not the answer, just for the record. And don't forget to say answer colon 5.2, which is not the answer. Okay, but that's what I expect from there. So you're going to stick the data into Excel. You'd be mad not to. You'll get the gradient out of it, and Excel will calculate that for you if you don't want to bother estimating it. But don't forget to say answer colon and then give me the answer, because that's what I'm looking for the answer. Okay, what does it represent? Well, I'm going to let you work that out. You've got volts and amps, so clearly we're looking at Ohm's law there, and you need to work that out. Spring rate, again, you've got data, stick it into Excel, get the line of best fit, and just be careful. I'm giving you the mass in kilograms and the extension in millimeters. I want the spring rate in Newton meters, so you've got to do some unit changing there. Time of a pendulum, oh man, it's messy for you. So again, just say I put the data into Excel, and look at this word here, emboldened. It says appropriate graph. What do I mean by the appropriate graph? Have a think about it, because it's the equation. Do I give you the equation? Actually, I do. That's the equation for a pendulum, 2 pi root L over G. So what are you going to plot against what? So be careful with that. And if you can't work it out, bring it to the tutorial. I'm happy to discuss it in the tutorial. Half-life, again, look at the equation. It's not a straightforward equation, so again I'm looking for you to plot an appropriate graph and then get the line of best fit. Yep, okay, I think that covers those questions, doesn't it? I think that's everything that we've looked for there. Right, are there any questions on that? Because I think that's right. They include Excel tutorial as part of their Scrum. Yeah, absolutely no problem at all. In fact, if one of the presenters wanted to do a description of how to do this stuff in Excel, you'll enjoy it, don't worry. But if anybody wanted to take the data, put into Excel and find the line of best fit, that's a good presentation for a tutorial. So yes, Sarah, that's a good thing to do. If I could like that comment, I would. All right, okay. Talking of likes, I posted a video yesterday. 34 people have watched it, which is 15% of the total. And do you know how many likes there are? None. Do you know how that makes me feel? Okay, any other questions? Thanks, Sunil. Right, shall we go and have some lunch?